This is an easy question, a 4-mark question from applications of trigonometry, heights and distances. We'll solve this question. This is question number 37. After solving this question, I'll leave you with one extra bonus question which is similar to this. Solve that question as well. Post the answer to that question based on the method that we are using for this question. Post the answer in the forums and comment section. Let's get started with this one. As observed from the top of a 75-meter high lighthouse above the sea level, the angles of depression of two ships are 30 and 45 degrees respectively. If one ship is exactly behind the other on the same side of the lighthouse and in the same straight line, find the distance between the two ships. We need to find the distance between the two ships. Let's say they are S1 and S2. Use root 3 is equal to 1.732. Let's get started. First one is the height of the lighthouse is equal to 75 meters. Let's draw two right triangles to depict what we are talking about. LG is the lighthouse we are talking about. This is the point from which we are observing these two ships S1 and S2. And G is the foot of the lighthouse. The height of the lighthouse is 75 meters. The angles of depression of these two ships, S1 and S2, from this observation point are 30 degrees and 45 degrees. So OLS1 and OLS2 are the corresponding angles of depressions, which are 30 degrees and 45 degrees. We know angle of depression is equal to angle of elevation. Therefore, the angle of elevation from ship S2 to this point of observation and angle of elevation from ship S1 to this point of observation at the lighthouse are going to be correspondingly 45 degrees and 30 degrees respectively. So GS2L will be 45 degrees. GS1L is going to be equal to 30 degrees. Let me assign two variables. The first one is X, which is the distance between the foot of the lighthouse and ship S2. GS2 measures X units. The second variable is A, which is basically the distance between the foot of the lighthouse and ship S1. What we need to compute is this distance S1, S2, which is nothing but A minus X. Let's get started by framing tangent or cosine or sine, whatever is appropriate trigonometric identity on these two right triangles, LGS2 and LGS1. Step 1, I'm trying to compute the value of X. So I'm going to look at right triangle LGS2. In right triangle LGS2, we have the measure of one side LG, which is a side opposite to this angle 45 degrees. What we are trying to find out is the adjacent side. So the appropriate trigonometric ratio to go with is tan theta. Tan theta is equal to opposite side by adjacent side. So theta here is 45. So tan 45 is equal to LG, which is 75, divided by GS2, which is equal to X. Tan 45 is a 1. So 1 is equal to 75 upon X, or X is equal to 75 meters. So found out X, which is step number 1. Quickly summarize it in a printed form. Tan 45 is equal to the opposite side LG divided by adjacent side GS2, which is 75 by X. Tan 45 is a 1. So X is equal to 75 meters. Step 1 done. Step 2, we're going to look at right triangle LGS1. We're going to compute the value of A. Here again, I'm going to go with tan theta because I know the opposite side, which is LG. I'm trying to compute the adjacent side's value, which is equal to A. So tan 30 is equal to the opposite side, which remains at 75, divided by adjacent side, which is equal to A. Tan 30 is a 1 upon root 3. So 1 upon root 3 is equal to 75 upon A. Cross multiply, we'll get the value of A to be equal to 75 root 3. So found out A. We already found out X to be as 75. So all that is left is to subtract X from A and find the answer. But before that, let's summarize it in a printed form. Tan 30 is equal to opposite side LG, which is equal to 75, divided by adjacent side GS1, which is equal to A. Tan 30 is a 1 by root 3. So 1 by root 3 is equal to 75 by A. Cross multiply, you get the value of A to be equal to 75 root 3. We need to find out the distance between the two ships, which is nothing but 75 root 3, which is A, minus X, which is 75. Take 75 common outside. It's going to leave us with 75 into root 3 minus 1. Take root 3 as a 1.732. So it is 75 into 1.732 minus 1, or 75 into 0.732. That works out to 54.9 meters. So distance between the two ships S1 and S2 equals 54.9 meters. Here is a bonus question. As observed from the top of a 100-meter high tower, the angles of depression of two cars are 60 degrees and 45 degrees respectively. The cars are on either side of the tower and in the same straight line. Find the distance between the two cars. Method is exactly the same. Even the trigonometric ratio that you should take is the same, except that we just change the values and that the two cars are not on the same side. They are on opposite sides. Right? Find the answer. Post your answers to the comment section and the forum section. Best wishes. Before you leave, do two things. Sign up at online.maxtute.com for CBSE online coaching for class 10 maths. It takes less than 5 minutes in all of 3 steps to get started. And do one more thing, subscribe to this channel, youtube.com/Maxtute, and spread the word about this channel to your friends and classmates.